Prafulla, you can go ahead and start your talk anytime you like.
All right, all right. Thank you. Thank you everyone for joining in this session. So in this talk, I'm going to talk about GrowthRx, the product that we built at Times Internet for analytics and the as a customer engagement platform. And in this product, we have used ClickHouse as a database to store all the native data and run the queries in this talk. And a little bit about the company. So I work for Times Internet. And Times Internet is a digital arm of Times Group. And Times Group is India's largest media business. And its biggest newspaper is Times of India, which is the most read English newspaper in the world. Uh, Along with the Times of India, it also publishes many other newspapers like Economic Times in regional languages of India, like Hindi and many other regional languages. Uh, in addition to that, we have presence in education, like we have Bennett University, we have presence in the radio, we have presence in our TV, music, and it publishes various magazines. And Times Internet is the digital platform for these things, where the digital newspapers like timesofindia.com, Economic Times, NBT, etc., they are published by the Times Internet. And along with it, we have MX Player, Willow TV, etc. in the business, and we have fintech and marketplace like Times Prime, etc. These numbers I put in just to tell you about the scale at which Times Internet gets the traffic. Like we have around 54 billion monthly page views, 133 million daily active users, and 600 million monthly active users. So the product that we have envisioned to build is the GrowthRx. And in this product, we thought, okay, let's build about the customer analytics and engagement tool. And the purpose of this product was to convert, retain, and engage more users. And the product has to work at the scale at which the Times Internet gets the traffic, which I presented in the previous slide. And so at a high level, we were thinking that, okay, we have to build a product which is around 40 to 50,000 records per second, which should be able to ingest. And we should be able to query the data of more than 5 billion records in a single query sometimes. And there should be a dashboard where multiple charts can be viewed and analyzed, so that, and while viewing the multiple charts, it means that simultaneous queries will be going to the ClickHouse database to process the data and bring out the data for the visualization purposes. Along with that, we have to also segment the users. We have to do a real-time segmentation of the users, so that we can target them by notification, by targeting them, sending push notifications or emailers. And at sometimes the segmentation site could be more than 10 to 15 million users. And all this we want to achieve by burning very less cash on infra. We don't want to spend too much on the infra. We just want to use infra optimistically. Next slide. So here I'm talking about the overall architecture that we took in this project to achieve this ingestion of events at the scale of 40 to 50,000 records, creating real-time segments, analyzing campaign reports, funnels, cohorts, pivots, and creating the dashboards. And in this architecture, if you look, it's just getting where the apps, there are the Times Internet multiple apps and the products, where there are as little SDKs running, which is sending the data to our APIs. And that API is putting the data in the Kafka, which is going to our creators cluster consumers are running behind this Kafka, and they are getting the data and putting in the ClickHouse. And then we have another UI for the dashboarding, which empowers our product management to load the data from the ClickHouse for analysis, etc., and view their dashboards. Now let's do a little more going deep in each part of this architecture. So let's do it. So first, let's talk about the data ingestion. So in this data ingestion, we are able to ingest more than around 40,000 requests per second. This what we have tested for the current scale. If it increases, we also tested that, okay, by just adding few more nodes, we are able to process even 1 lakh records per second. And all this, and if you look at the architecture, it's simple. The apps are sending the data to our API with the multiple instances of these APIs running, which are putting the data in the Kafka. And there are the consumers running, which are putting the data in the ClickHouse. So why we chose this architecture? Because ClickHouse says that, okay, do not do too many inserts, but insert data in batches. So the purpose of these consumers is to batch the data and put it in ClickHouse in one shot. And all this we are able to achieve on just 3 VM ClickHouse replica, and where we have 10 TB SSDs on each machine. And all this we have achieved because the ClickHouse has a very good compression, which keeps the data at the size of the data at disk size is very at minimal. Okay. So once the data is ingested, then the next part was to run the segmentation queries. Our segmentation was a little complex, where we have to empower our product managers to define queries like subscribed users. They should be able to, let's say example, like there are users who are subscribed and they are reading our tech news on our system more than, let's say, 5 days, 5 times in 2 days, and they have not visited the sports section. So ClickHouse has a very good feature of bitmap functions. Now what we can do is we can think about this query as the 3 parts, like users who are subscribed users, create a bitmap state of these users, then users who are reading tech news more than 5 times in 2 days, that is another group bitmap state that we have created here, and then just do a bitmap and between these two functions. So then it will say, okay, give me all the users, read tech news, and who have not visited, then we can do a bitmap not over all these two things. So this gives us very much flexibility to comprehend the statements that are given on the UI by the product managers into the ClickHouse query, because we can easily slice and dice these queries into different bitmap states and then just do a node. And this bitmap states are pretty fast, where we are getting processing speed of more than 200 million rows per second while processing. So this way of your segmentation helps us in fulfilling the criteria of where we can segment, getting the results of more than 50 million users, and segment and do a push notification at real time very fast. Okay. Now the second part was the dashboarding. In dashboarding, we have to support multiple charts are there, and each chart can have multiple data points where we are showing for the trends analysis, let's say trend this week, and compare it with the trend last week and maybe the trend with the last week of the last month. Because there are multiple charts, and just to keep the ClickHouse database, because every query means there is a need of CPU and the RAM to process the data, what we did is, like, we just take the chart in the API, we just put it behind the Kafka and make it asynchronous. So all the requests are coming via Kafka. Our consumers are getting the data from the ClickHouse and then putting that, after evaluating the data, it's putting in the object store. And then basically the UI is pulling the data from the object store to display these charts. So this way we have achieved the asynchronous execution of these queries instead of too many parallel requests coming to our system. And also now we are able to show multiple charts on the screen. And then how do we make this query run faster on billions of records? It is by using the sampling feature that is provided by ClickHouse. So let's talk about these key features that we have used to generate our dashboard. So the 3 features that we primarily use for dashboarding are the metallized views, the sample clause, and the parametric aggregate function. So I will explain this in the next slide. So here's the metallized views. So what is a metallized view? So metallized view is a summarized view of raw data. So what we can do is, let's say there is a table where we are getting, okay, against every campaign, we are storing the data. Okay, this user has received the notification, user 2 has received the notification. That is the raw data. And then we can create a metallized view where we are storing, okay, against this campaign ID per day, just store the count by doing a query over the main campaign table, where we are doing a just simple group by over the tenant, just product, and the campaign and the date. And the ClickHouse will start automatically populating this table. Now, because the data is summarized, it is very easy to generate a trend or query this table. This metallized views helps in minimizing the space. And also because now space is minimal, we can store this data for longer duration without spending too much on the disk. And the best part is we can create multiple mat views over a table so that in one way we can say, okay, give me the count around the campaign ID. In some way we can say some other requirement where we want to say campaign ID by device we can keep. Right? And so this way it becomes very easy to generate the campaign reports, and the power user curves also we are able to derive based on this, because now we are keeping the data in the summarized manner. The next part is the sample clause. So most of the times, if we want the data, we don't want an accurate data, but the approximate data is enough for the trend analysis. So we use the sample clause from the ClickHouse. So in this query, when we say sample 0.1, it means if there are 1 billion records to be evaluated, it will evaluate only the 10% of the records. And with that approximation, it will give us the result. For the large, so in our system, we have observed that when the record data size is very large for more than 1 billion records, so we can easily use this sample size to speed up the queries, and the results are approximately same. For example, in our case, we have seen that if the records are more than a billion, we can easily, when we multiply this count by 10, we are approximately getting the same data if we don't use the sample clause. But the query processing time is improved drastically by using the sample clause. But the trick here is to figure out the exact sample clause for your query. And for that, because we understand our data and we know, okay, for this product, how much data could be there for a query. So based on the data set for a product, we have calculated the sample size. And that sample percentage we put in our query, and we are able to get the approximate results which are near to accurate. The second part was the parametric aggregate functions by the ClickHouse. This parametric aggregate functions in the helps us in creating the funnel view for our dashboards. So what is the funnel view is like, let's say the users who are, we have got leads, and the users then have got converted into prospects. And when we targeted those users and the users who have responded, they will fall into this bucket. And once the users have responded, how many we have won as the customers. And to generate this view, we don't have to write any complex queries. We just use the window funnel function in which we can pass the event names as the sequence like leads, prospect, along with any where clause we want to put in this function. And this function gives us the count as for each events and also the users who are part of this funnel. And then we can target each user separately from this segmentation. So that's about this. Thank you very much. Any questions?
Thank you, Prafulla. That was a great talk. For folks attending, if you would like to ask questions, please go ahead and post them into the Q&A box. While we're waiting, Prafulla, I have a question. Maybe you could, I liked your examples of using sample. And how did you figure out the right sample size to use? That's an interesting trick, because it's sort of balancing the quality of the answer versus the speed at which it obtains that answer.
So in our case, we have different products as different tenants, and we pre-calculated how much data each tenant has. And that and based on the data size, we have identified, okay, if the records are 1 billion, then we will go with the 10%. If the records are 500 million, then we will just do the 5% of the sampling. And we just kept this sample factor in our some cache. So while creating the query, we pull out this sample size from this cache, and then use it. And then we used to pre-compute this sampling factor on daily basis.
Mhm. Great.
So
Thank you
does
very
that,
much. We have another question from the audience from Carl Axel. How do you track user identities? For example, joining logged in and logged out users. And are there any learnings from that experience?
sure. So for that, we have created a profile table in ClickHouse. And whenever a user is logged in, so we have our own SSO and we keep the SSO ID of that user in our system, along with the unique user identifier that you always create, whether the user is logged in or not logged in. So if user is non-logged in, then we have a unique identifier in our system that we track. And once the user is logged in, we keep on updating the profile table. And in the profile table against that ID, we keep the logged in user ID as well.
Great. Thank you very much. Any further questions from the crowd? Got a good number of attendees here. Okay, I don't see Prafulla, I don't see any additional things coming up. Thank you so much for a great talk. It's really well organized and really informative.
Thank you. Thank you. Thank you everyone for attending the session. Thank you, Robert.
All right, thanks everybody.